In this video, this is an introductory video to probability in Year 13 Maths, and just want to cover briefly to make sure that we're secure on the language and the symbols that we're going to be using, and we might have a look at one formula as well, but shouldn't be anything that's too unfamiliar at this stage. This is really just making sure of some essential things. So I'd like to look at this in two contexts, a Venn diagram context, and then also we'll have a look at it in the context of a tree diagram. Both of these things I believe you should be familiar with. So the crucial thing really to think about are the symbols to begin with. So if we have a look, we might talk about in the context of this sort of Venn diagram, we might have two events, A and B, and the possibility that neither of those things might happen as well. So we've got everything that's event A contained within the left-hand oval shape, everything that is the event B contained within the right-hand oval shape, and anything that is not either A or B is in the box outside both of those two oval shapes. So we talk about, for example, the probability of A. So just to be clear about what I mean, what I'm talking about here, probability that A happens, well, I could work that out by whatever numbers I've got in the various different regions, just having a look at the regions that represent whatever A is. So we'd be looking there at A being the blue section plus the purple section. We'd also think about the probability of B happening, and in terms of which regions I'm looking at there, I'm looking there at the sort of orangey, muddy orangey colour section, and then I'd be also including that purple section. So if we talk about A, we're not really thinking about whether something else might have happened as well or anything like that. It's just the case that A has happened, so I need to be including everything that's within the A oval shape. We can also talk about things not happening. So for example, I might talk about not A, and I use a particular kind of symbol for that, for saying that something hasn't happened, and I'd be talking about the probability that A has not happened. I'd be using a little dash on it there. Some people say A prime, other people just say not A, probability of not A, or probability of A prime, that kind of thing. And so for that sort of thing, I'd be looking at everything that is outside of the A oval. So that's going to be the green section around the edge and around the outside. But it's also going to include the orange part of the B oval, but not the purple bit. So the orange bit from the B oval, but not the purple bit, because the purple bit is inside A, so it doesn't form part of the not A section. Similarly, I can talk about things being not B as well, so I'm sure you can work out how that would work. The perhaps most crucial bit of this diagram here is to be thinking about the bit in the section, the purple section, and this is where I want to start talking about words, the language that goes with it. So the word "and" is a key thing to watch out for when I'm talking about two events. If I talk about, for example, A and B, then I can represent that with a symbol which looks a bit like an N shape. It's actually not quite an N. It's just well, it's more like an upside down U really, but I kind of think about it as being an N as well. And so I might talk about, for example, probability of A and B. And when we talk about ands in probability, we mean that both of the things must have happened. So it's not either one or the other one of them, and possibly both. It has to, if I say A and B, I must be including both of those things. And in the context of that N, that and, represents an intersection, is what we call an intersection on the Venn diagram. And so that would, in terms of the colours on my Venn diagram, that would just be the purple section. Oops, sorry, not purple. It would just be the purple section from my Venn diagram, A and B. And now I can combine intersections and that N thing with various different things. I can combine those with some of the not things now as well. So, for example, I might be interested in thinking about all of the what's the probability, let's say, probability of A intersection or A and not B. So A intersection B prime, like that kind of thing. Just give it an extra little bit there. Probability of A intersection B prime. So that's the implication there is that it's everything that is both in A and outside B. And there's only one part which is both in A and outside B, and that is the section that I've shaded in blue. Which blue was I using? Was it that one? I think it was that one, wasn't it? Yeah, that one. So that section there would be the bit represented by A and not B. And the final symbol to think about is, and the final word that goes with it, that I want to think about here in this section, is the or possibility. And symbolically that gets represented by the same kind of symbol as that N there, but the upside down version of it, so it looks like a U now. And often the word that's used here for this one, where intersection is used for the N, for the and, the one that's often used for this U or the or is the union. So I talk about probability of A union B, or we might say the probability of A or B. And the way we need to understand that or in this context is that it can be either one of those two things or even both of them. As long as one of those two things, A and B, have happened, then that would be included in A union B. So that actually is represented on my diagram by three sections. It's represented by the section that I've highlighted in blue. It also includes the intersection bit, the part that's in purple on my Venn diagram, and finally it's also including the part that I've highlighted in orange. So all of the stuff that's inside both of the both of the oval shapes. And you may remember from last year, I hope you remember from last year, something called the addition formula, or the addition rule sometimes called. Actually, it's sometimes called the addition law as well, which gives us a formula way of working out A union B. So you might be familiar with this formula, which goes probability of A union B is equal to probability of A plus the probability of B. Oops, sorry, I forgot to close the bracket. Plus the probability of B, and then we have to subtract one of the intersection, the part in the middle, A and B part in the middle. And that's because if we just do probability of A and add the probability of B, that overlapping section is counted twice, so we need to remove it once. And so there's the addition rule, the addition formula, the addition law for calculating the union, probability of the union things. I also want to have a quick look at a tree diagram before we move away, which I have now just put in slightly the wrong place, haven't I? So let's just give ourselves a little bit more space here. And so here we're thinking about two events, or more sort of in sequence, a kind of time-related thing. And so we'd be thinking about the first section, the first division of the tree diagram, perhaps as being A. It doesn't necessarily have to be; it could be B first, but whatever. A. So at the first stage here, I might have A has happened. Or the other alternative at that first stage is that A didn't happen, and so that would be a not A. And then at the second stage here, we've got a B happening or a B not happening. Generally speaking, what we do here, we label probability values alongside each branch along here, and then, for example, if we want to work out what's the probability of A and B happening, we'd follow the route through. So we'd be going along the yes, A did happen, and then we'd be following along the branch that yes, B did happen as well. And so by the time we've got to the end, we take the probability numbers from those two branches, we multiply them together, and the outcome that we get at the end is the probability of A and B both having happened. And we now know that when it's an and, that's the same as an intersection. So I get at the end of that, by multiplying those two probabilities along the way, I get the probability of A intersection B. And so I can finish all these ones off as well here. This one here, this outcome at the end here would give me the probability of A intersection not B. Sorry about my B's, by the way, I'm not very good at writing B's on these tablets. This third one would be the probability that not A happened, but B did happen, so that's not A and B. And then the final one down here is the probability that not A happened and also not B happened. So there we are. That's just a quick look there at the language and symbols that go with probability, and we're going to fill in a few more details on that in subsequent videos.